Hello, a very good morning, great hopes. I'm Rollins and I'm back for your mathematics, and I'm happy that you beginning to see the shape as we are dealing with the topic of polynomials. Today we are going to be reinforcing a bit more on what we started to build up in terms of polynomials. We talked about how you look at a general expression, and you can use different ways to factorize to make it simpler. And we said apply these things in your life in terms of when you have a problem, factorize the problem, try to look at the factors affecting your life and solve them one by one. It becomes an easier thing than to attack it as a monster like that. So with that, yesterday we looked at the part of cubic functions, and we mentioned what is a cubic function and how it's structured. And it is any expression where the order of x is 3, which means that you have x cubed, like that. So we began to look at how you can actually factorize such a big, gigantic expression. For example, if you want to divide this expression by x plus 1, we use the long division, and we found out that you can actually utilize it until you get a final result, which in this case carries a remainder. And such a remainder can now allow us to write the expression according to the quotient there and the remainder. So that is our quotient, and that's our remainder. Okay, and that means you can eventually write this expression in this format. Kind of easier to understand it in this way than it was at first. So we analyze it and put it in terms of, and even the remainder. So it's a complete solution at that stage, though you can actually refactorize again the quadratic part. Using the very same question, we also looked at how you can use synthetic division, and with synthetic division, you are sort of using a shortcut. You are a bit lazy to go through the long division, so you use the shortcut by deciding that you are going to take the x plus 1, which is divided. So you make the root of this would be minus 1 if we were to equate it. So we take that minus 1 and we put it outside the division sign, and then we have coefficients, like there's 1 here, so you put the 1, the 2, the minus 1, the 3. Then from there we pull down this one as it is. We just put down this number as it is, and then from that point we start to multiply this and that, and we get a result here. So you multiply minus 1 times 1, you get minus, and then you are always adding. So 2 minus 1 added together gives you 1. So you continue again by now multiplying this one to the next number on the bottom, and so forth to get all this. Eventually, in the end, you know that your answer is that you take the division aspect as well as the quotient, so this is like a quotient, which is this. So that will be 1 degree less because we have divided by x. So your first coefficient is now x squared. So that's how you come up with it. And then this is your remainder. So by using this, you start to see that you have actually found a way of doing a shortcut of factorizing polynomials. Okay, so that's how it would work. We also started to look at a few questions. For example, we said, what is the standard form of a polynomial? And it is this one, because that's the only one with a key in the order of x. Okay. We also had an opportunity to do some online assessments on your device, and we are going to have a couple more of those when we actually continue. And you'll see that you also could use the long division, which we did, and we got a solution from the long division, which was that D. So we had to use the long division method and got to a result. So with that, we could start around this point. And I must remind you at this stage that we will be having our online assessment, which you can actually join in and interact with the teaching resources that we are giving you, as long as you have a laptop or a smartphone that can go on internet. So let's try one at this stage and see how far we can go. Okay, so remember, for all our assessments, we should actually go to hellosmart.com. And when you're at hellosmart.com, you will be prompted to put your name, and also you put an ID number that is 598751, the one we were using yesterday, and you sign up as a guest. So just go to hellosmart.com and you fill in this detail, and you are already in the assessment. Remember, our lessons are smart caps. So by interacting with the material, you'll be able to actually give us live results or your contribution on the questions and so forth. And we are happy to remind you that this is being made available to you for free because it is sponsored by VT Africa Holdings and the Department of Education and other sponsors. So with that, we are going to try and get the remainder of that expression. And if you want to join in, the details is on the board. Okay. So let's then so that would be when we are looking for the remainder of that divided by that. So if you are using a piece of paper or your handbook, try work out this question, dividing this by that, and we want to see what you can come up with. So do your best to cover that. Remember, I can employ any method if you want to use the approach where you are going to divide this by long division or by synthetic division, or maybe you want to use any other method that you know by now in grade 12 to factorize this particular expression. It's all welcome because we simply need an answer in terms of A, B, C, or D. So it will be all up to your choice. Okay, just a second there. Yes, I'm trying to connect you further. But if you have copied the question, you can be busy with it while I'm reconnecting you, those that are on the device. So there is our question, and let's look at it by now and find out how you can solve. So say let's use the long division for this one. So you can use any other method. So it's just our choice that we can use a long division. So you will say x minus 1 dividing into x cubed plus 2x squared minus x plus 1. And with that, you start by saying x into x cubed, which you get x squared. And then you multiply this to the x again, which gives you x cubed minus, then that x squared multiplying minus 1 will give you x squared, which is negative. So we multiply by factor that is dividing. Then when we do this, we always subtract the whole result of the subtraction. So the first one is giving us nothing because it's x cubed minus x cubed, which, and then the second part we have 2x 2x squared minus x squared. So be careful of the two minuses in this, which will give you 3x squared, because eventually you're adding because of the minus. Then what you do at this stage, you bring down this minus x. So you now have minus x from above, and you divide again with this one. So x into 3x squared will be positive 3x. And then when you multiply it with the same, with 3x squared, then 3x times minus 1 will be minus 3x. And we always subtract this result, and we get 0 for the first subtraction of 3x squared minus 3. And then on the second part, minus 1x minus 3 will be actually like minus 1 plus 3. So minus 1 plus 3 is positive 2 with the x in this case. Then we bring down this number, and then it gives us what we can put. So if this is 2x, this being 2, let's write it like this. If this is 2x from subtraction, then after bringing down the 1, we have, and again, we divide this into the 2x, and we get just 2. And then we multiply that 2 with the x minus 1, and we get 2x minus 2. Okay. So this, when we subtract, will eventually give us 3, because that will be 1 minus 2. And if you didn't make any mistake, you see that your answer is, which is a 3. So there is your answer, A, which means, as we have said, this will be your remainder. Okay. So the number there will be your remainder, and that solves the question with 3, the solution at B. Okay, what if you are asked this question, that which of the following statements is false? So you have to do a few of the divisions here. You have to divide all this by this. So you are going to divide all that by this, all that by this, all that by this, and see if you get the rest of the expression on that as your solution. So you want to try that. You want to check which one could be false. So you can even make your guess and start with the one you think is false. Not a problem, because you're looking for one answer here. But you could also sequentially start it from A, B, C, D, checking each one of to find out which one would give you a false result. So I want to give you a few moments to actually look at it. Let's have your feedback if you are connected to our response. So at Hello Smart, you can actually give us your response. So let's give you a minute to look at it and find out. Okay, I trust that you are making some progress, and we want to give you another 30 seconds to finalize your solution on this one. Which one is more correct? So look closely into each and every one of these and check the one that is false in this case, which means the other three are correct. All right. So if you were doing everything correctly, you realize that at this stage you have checked all this, and just by looking at it, I was able to divide this and check all these remainders and so forth. So I saw that the first one is correct. So is the second one. This one didn't give me 24 as the remainder, and this one was correct. So if you did everything correctly, you see that your answer is C. And I worked these mentally by looking at that, but you should actually use the long division or the synthetic method as each way and to get your solution. Okay, so your answer there is C. That's the false result. There is another interesting one. Use the synthetic division to find the remainder, and x cubed plus x squared plus 1 is divided by x plus 2. So you want to use the synthetic division method to get to your solution. So remember, the synthetic division method is sort of like the shortcut, and you are going to try it and see what you can get. So do your best to find out. I hope you are moving. Those that are stuck on remembering the synthetic, I'll just give you a hint of it. 1, 1, 0, 1. Where is that coming from? These are coming from the coefficients of the cubic expression that is given, where your cubic part of it is a coefficient of 1. The squared part is 1. We don't have a x there, just x to the exponent. We don't have exponent 1 for x, so we represent that by, and then we have 1 as a constant or as just a number at the end there. And remember also that if you are dividing by this, it will give you -2 as the number that you are going to multiply with throughout. So consider all that in your solution, and you should come to a correct expected end. Do your best with that. So there's enough ammunition that I've given you as a hint to actually solve this monstrous problem and dissolve it into something approachable. So if you remember your stuff, let's see what you might have started to do. So then you are expected to have said 1 comes down directly here. Okay, so 1 you always pull it down, and then you start to say -2 times the 1, you get -2. You write, then you are always adding in this case. So don't confuse. So when you add 1 and the minus, you get -1. And then you multiply the -2 with this -1 again, and then you get +2. You add the 2, you get 2. And then you multiply -2 with that 2 again, you get -4. And again, you add these 2, you get -3. So your expression, your answer you're looking for is that. So that is your remainder. And if I wanted to write this expression in a simpler way now, I could say x cubed plus x squared plus plus 1 can be expressed simply as x plus 2 into x squared minus x plus 2 remainder 3. So that's how I could write it, and I'm getting these pointers from here, from there, from there. So that's where I got the coefficients to put into my quadratic part. But the question simply wanted you to tell us what is the remainder. So your remainder will be A, which is -3. So I hope that you now have a good sense of the synthetic method or division. When I was at school, we didn't do the synthetic division. We had our other methods of short division and all that, but I was taught this method by other learners who actually use it in other schools to get to a solution using a shortcut. So it's very good to be divisive and show some creativity in solving your problems. Okay, we are also going to look at a much simpler way of solving polynomials using what we will call the remainder theorem and the factor theorem. So this will be our last tool or weapon that we can use to kill this particular monster. We can use the remainder theorem and or the factor theorem. The remainder theorem states that when a polynomial is divided by a factor, then f of x, which is the expression there, f of x divided by x minus c is equals to f of c. So that can also be expressed if we have f of x divided by ax minus c, it will give us f of c over a. Sounds very abstract and confusing, but you'll see that it's much simpler as it were. So you can note that here you have no need to prove this at this stage because it's not examinable, but we want to prove it in the practical part by using it in particular questions so that you understand it better. For example, use the remainder theorem to find the remainder if x squared minus 2x plus 1 is divided by x minus 3 or by x plus 2 or by 2x minus 1. So what you're going to do here is to use simply going to choose what factor we can get, what is the root of the division. So if we were to make x the subject here, that we would have sort of like x equals to 3 from this part. So we go now into the expression and say, what is f of 3? The same 3 that we got there. And then that will give us 3 squared minus 2, 3. So we are replacing every x from this expression. And what do we get? We get 9 minus 6 plus 1, which is equals to what? Which is equals to 4. Okay. So 4 is the remainder if that expression is divided by that. So you see how simple it is. You simply substitute the root of your division. In other words, you equate it to 0 and you find what x equals to, and then you substitute x into that expression. So let's look at how the rest of it was solved for you. The other one was dividing by x plus 2. So we put f of x, f of minus 2 in there, and we substitute it in all the expressions to get 9. So 9 is the remainder. Then the other one was given in such a way that it was x, 2x minus 1. So we're dividing by 2x minus 1, as you can see. 2x minus 1. So with that, you also make x the subject, and then you get, and you substitute that half to get a quarter. So that is your remainder. And I believe that this is a more easier method and very quick to give you your solution of the remainder or the factors as usual as we go. So it's a very useful method. So this is a question to check if you understand the remainder theorem. The remainder theorem states that if x minus c is a factor of f of the remainder is 0. Or is it stating that if f of x is divided by x minus c, then the remainder is f of c? Or is it saying that if f of x is divided by x minus c, then the remainder is 0 and x minus c is a factor of x? Okay, so if the remainder is 0 and x minus, then x minus c is a factor of f of x. Or does it say that if f of x is divided by x minus, the remainder is f of negative c? So I see what is happening here, that we just looked at this and we saw that our remainder comes from that. And we want to also mention that this is also a correct statement though. And it's going to be shown when we are dealing with the factor theorem. So is a factor theorem. So far, we are still dealing with the remainder theorem. So we will look at it when we are dealing with the factor theorem, like that. Okay. So in this case, according to the progress of our lesson, I would say that B is the answer because we haven't yet covered the factor theorem. If you like, so that would be the case. So it will be B as you see. Though C is also correct, as we shall see in a minute. Okay. Find the remainder if that is divided by it. Check this one in just hardly 30 seconds. You can get your answer. That's the beauty of the remainder theorem and the factor theorem. You simply substitute and you get your answer right away. So try it and let's see what you can get in a few minutes. Few seconds rather. So do your best to check it out quickly. Okay, so by now you could have actually got the answer. I can promise you that if you are using the remainder theorem, it's very quick. So let's look at it because our time is running out. We are simply going to substitute x minus 2 from this and so on. By doing that, we know that our answer can only be A or B, because the other ones are not following the remainder theorem. So with that, we now substitute into our expression and we have minus 2 squared minus 3 that and that. So if you do your computation correctly, you see that you have 4 plus 6 plus 3, which will give you 13. So your answer eventually is at A. So your remainder will be 13, as we have shown. If you were timing me, you'd see that I took hardly 30 seconds, though I was pausing to explain some of the lines. So you can do this very quick, and it's the beauty of discovering tools that can help us to make life easier. How about this one? How can you solve it? The same way. Look at it very quickly. So that will be our last question for today, and we want you to start practicing with the remainder theorem, which makes life very easy when it comes to polynomials. You see that it applies even to quadratic expression. It's not limited to polynomials of the order of 3, but you can use it variably. So to finish up with this one, let's do it together. We just say x equals to 4, and then 4 cubed minus 4 squared plus 4 minus 9. So those with calculator should help us to get a final answer here. So check what you can get from this. Just find out what you can get. So I think this would be like 60 ohm minus 16 plus 4 minus 9. So you end up with something that is around this. So check it, and we want to discuss this in our second is one of our point of entry, and I'll leave you also with one more for your homework to practice using the remainder theorem. So find out what is the remainder of if f of x is given like that, and then it's divided by 2x minus 1. So on that note, I would want to thank you, grade 12s. I believe that being that it's your final year, you are putting a lot of effort in changing your whole scenario, studying. If it takes you through the night to study, then let it be. It's just for the final year, and it's worth it. And maths cannot be studied by looking at them like you are viewing a program on TV or on the computer. It's something that needs you to practically touch and mingle with the maths itself in order to pass. So I would want to thank you. I believe you have copied the question. And on that note, I would want to thank VT Africa, which has sponsored this list of smart caps, as well as other wishes like the Department of Age, Fiber Tech, and Vasta Tech. Thank you. Have a great day.